Flack math! Give me some math and I'll give you some flack. Flack math!
So linear systems of equations. So that's, remember when we had this thing and we had y equals 1/2 x minus 1, and then y equals 3/2 x plus 3. And then what we could have done is we could have plugged this into that y and then solved by substitution. We can also solve by elimination, but we're going to solve by graphing. Okay, so graphing, there's infinite number of x's and y's that will make this equation true, right? For example, if x is 0, y is going to be -1. If x is 2, y is going to be 0. If x is 4, y is going to be 1. So you can do the same thing here. If x is 0, y is going to be 3. If x is 2, y is going to be 6. If x is 4, y is going to be 9, and so on. Okay, but there's only one xy combination that works in both of those equations. Okay, and graphically, this is a line and this is a line. So where is that common point going to be on the graph? Well, let's figure it out. Let's graph this. How do you graph y equals 1/2 x minus 1? You remember? Well, we could just pick a bunch of x's and y's that work, or we could do the shortcut.
I tried not to remember anything from algebra.
All right, good. That was good. That was well.
Didn't you create like a table
What?
for that different thing?
You could, yeah, you could create a table and do it that way, but it's already in slope-intercept form. So when y is by itself, that gives you the slope and it gives you the intercept. Because if you have a point to start and you have a direction to go, then you can draw the line, right? So here's the intercept. The intercept is right there. And the slope, which is completely separate from the intercept, is right there. So the slope is what is being multiplied by the x. And the intercept is where the line crosses the y-axis. So the constant right there. Okay, so let's see, the intercept is at -1. So right there, that's where we start. Okay, so this is the y-axis intercept. So that -1 is right there. Okay, so slope, what does slope mean? What does slope equal? Rise over run. Okay, so it needs to be in a fraction. If it's not already a fraction, make it a fraction by putting it over 1. But look, it's already a fraction. So how much does it rise and how much does it run? +1, it rises 1. So from here, it rises 1. And then what does it mean to run +2? To the right, 2. So it goes up 1 over 2, up 1 over 2. Up 1 over 2. So this is what this line looks like. Okay, that's pretty cool, right? See how we didn't have to do any of this because we just had to start here and go this direction. Start here and go this direction. Okay, so let's start at +3. See that? +3. And then what does it mean to go in the direction of 3/2? Up.
Up 3 over 2.
Up 3 over 2. 1, 2, 3 over 2. So if I keep going that way, see how it's going to get farther and farther away from this line? So let's go the opposite direction, which is the same slope. Instead of going up 3 over 2, let's go up 3 over 2 from over here. Or down 3 left 2. Down 3 left 2. Down 3 left 2. Okay, so basically it's going to cross about right there, which is, if I graphed this perfectly, it would have been a nice, beautiful combination. But that is, looks like it's basically at -4, comma, -3 maybe. -4, -3. Let's see if -4, -3 works in both of these equations. Okay. Maybe -4, -4. Let's try that. What happens when you plug in -4 there? You get 1/2 times -4. What's half of -4? -2 minus 1 would be -3. Okay, that didn't work there. So we wanted to get that. So maybe it is where, yeah, I think we're gonna do it. Yeah, we're gonna do it. So this was a -3. So let's see if -4, -3 works in this one. What happens when you plug in -4 for that x? What's 3/2 times -4? 3/2 times -4. So -4 over 1. Cross reduce. So you get -6, right? -6 plus 3 is -3. So it works. So that works in both. So if you graph both of them and use graph paper and a ruler, and you won't get it wrong. But this was a little weird because I'm just kind of random. I'm not perfect. I know some of you think so, but I'm not. I'm not perfect. So if you don't use graph paper, you're not going to be as precise. Okay. All right. So that, and we've done this before where we could have replaced, just use substitution. So if this is what y is, we can plug that in for y. And then we would get, instead of y equals 3/2 x plus 3, we're going to use y's new wrapper name, which is 1/2 x minus 1. Yo. Okay. We're going to say 1/2 x minus 1 equals 3/2 x plus 3. Okay. All we did was substitute that value in for y. Since that's what y equals, we substituted in there in the other equation. So now if you solve for this, let's see. Get rid of 1/2 from 3/2. And what does that equal? You get 1. You get 2/2. So this simplifies to x plus 3 equals -1. So get rid of 3. X equals -4. So if x equals -4, let's figure out what y is. So plug in -4 and you get -3 for y. Okay, this is solving by substitution. But since we're in geometry, we like to solve graphically so we can see it. All right, let's try another one. Let's try example 3 here. Okay, I'm going to graph 3 of these to see if there's a solution. I'm going to graph, let's see if these 3 converge at one point. Y equals 2x minus 1. Y equals 4/2 x plus 2. And 2y minus 2 equals 4x minus 2. Okay, I want to solve, I want to graph all of these. Well, what do I need first to graph? What's the easy way to graph? Yes.
You need to slope-intercept.
Okay, so the top one is already in slope-intercept form, kind of. But remember, slope is a fraction. So how do you turn that 2 into a fraction? Just put it over 1. Okay, that looks like a nice fraction already. This one, slope-intercept form is just y by itself. When y is by itself, the other side reveals all the secrets. Okay, so let's get y by itself. Let's get rid of this 2. So then we get 2y equals 4x plus 0. Okay. And then get rid of 2. How do you get rid of 2? Divide by 2. So y equals 2x. Okay, so now all of them are in slope-intercept form. What do you think is going to happen? How do you graph y equals 2x minus 1? How do you graph that? Where do you start? You start at the end. So down one, so this is the y-axis intercept. So it's down here. And then what's the slope of 2 look like? Up 2 over 1, okay, up 2 over 1, up 2 over 1, up 2 over 1. So it looks like that, okay? What is y equals 4 halves x plus 2? So that starts at 2, right? And then up 4 over 2 looks like that. So this one looks kind of like that. Okay, and then y equals 2x. Where's the intercept? I don't see an intercept. There's nothing there. I couldn't do quotes without flipping people off. So that's the y-intercept is just 0. So that looks like this, and it goes up 2 over 1, up 2 over 1. So what kind of lines are these? Parallel lines. You know what gives it away? There's no solution because they will never intersect. They have the same slope. So parallel lines have the same slope, right? Because what's 4 divided by 2? 2, 2x, 2x, and 2x. They all have the same slope and different y-axis intercepts. What happens if one of these would have the same y-axis intercept? What if this was 2x plus 2? What would happen?
We have 3 equations. We need a solution to all of them, not just 2 of them, right?
Well, what if this was a 2? How would you graph that? It would go right on top of this one. It would be the same equation. So you would only have 2 equations.
Oh.
Okay? So there's no solution. All right. Now you don't have to go through all that work because as soon as you identify the slopes, look to see if you have parallel slopes. If you have parallel slopes, the same slope, then you don't have to do any work. You're done. Just say no solution. Okay? All right. Does that feel all right? You guys good? See, we're moving along. We're moving along. The official answer to these types of equations are called inconsistent equations. This is called consistent equations because consistent is like a positive term, right? We like that. It sounds positive. I'd rather be consistent than inconsistent. Okay? So consistent is when you have one solution. Inconsistent is when you have no solutions. There's a third one that's called dependent, and that's when it is the same equation. So a dependent person, like to me, like a dependent child, is one who cries when someone else tries to hold them besides their mommy. Okay, that's the dependent child. They're very clingy. They're just attached to their mom the whole time. Okay, that child will grow up and live in their mom's basement until they're 46.
So were you a really clingy child?
Yeah, actually, my mom lives in my basement. What's up, Mom? Living in my basement. Are you clingy? Are you clingy? Are you dependent? Are you dependent? Are you dependent? No, I love you, Mom. I picked her up from the airport yesterday. Sat in like 3 hours of traffic
Where was she?
because I love her. She went to Oklahoma, I think, to visit her sister-in-law.
Your
Okay.
brother did the same thing in biology. Like, and all the kids of the tree, they should spread out so they don't use resources, right?
Yeah.
Not stay at home until he's 23.
Yeah. Yeah. But, you know, there's actually, it's on one of my videos where that I made last year. I was doing a lesson and my mom comes in. She's like, Michael, what are you doing? But we planned it. But anyway, she was like, Mom, I told you not to bother me when I'm teaching my lesson. You should watch it. It's funny. Okay, moving on to 82. Here we go. We're gonna do more applications of trigonometry. So more trig. So remember, trig is basically the math of right triangles, okay? So let's do a little bit of review here. You guys remember SOHCAHTOA? Okay, so sine equals op over height. Cosine equals adjacent over height. And tangent equals op over adjacent. Okay, so far so good. That's SOHCAHTOA is just a little acronym that helps you remember all the different functions of trig, the trigonometric functions. Okay. So there are some more functions. For example, the inverse sine is the measure of an angle where the sine ratio is known. Okay, so if I did this, if I did the inverse sine, hold on one second. Okay, so if I want to figure out an angle, now real quick, let's do just a real quick example here. Let's say this is 5, and we want to know x, and this is 30 degrees. So how would you find x? You guys remember? We can use a trig function to find x. Because right now we can't really find x, but we can because we know that this is a special triangle, but let's ignore that for now. Yes?
Well, you could do 30 plus 90 minus 180.
Okay, so that's 60, but that doesn't give us x, that just gives us that other angle.
Well, but can't you do that, the 60?
No, because we don't technically know the bottom is, if the bottom is the short side or the long side, right?
No, it's the long side.
We do?
Yeah. Now, we know a 30, 60, 90 triangle, this is always twice, so that's 10. But if we didn't know the shortcut,
Wouldn't it be tangent?
how can we use trigonometric functions? Well, we're given this angle 30. So what sides are in question here? What sides are we dealing with? According to what side, do we have an adjacent side to 30? Do we have an opposite side to 30? Do we have a hypotenuse? What do we have?
Have an opposite.
Opposite. So see how this is opposite, this is adjacent. So sine equals op over adjacent, right? So 5 over x. Sine of 30 equals 5 over x. Does that make sense? That's just all I did was the sine of an angle is the side opposite of that angle across the pond divided by the hypotenuse of the triangle. The hypotenuse is x. So to solve for x, we need to multiply by x. We get x times the sine of 30 equals 5, right? Well, the sine of 30 is just 1/2. X times 0.5 divided by 5. Okay, so let's see here. When I divide by 5 by 0.5, I get x equals 10. Okay, so that's using trig to find a missing side. But what happens if I want to find a missing angle? Let's say that we're not given this 30.
Then you replace the anchor. Depending on what you have, you replace the angle with x. You just have both planes, right?
Right. So here's the deal. This is something that you need to learn on your calculator. So if I want to find the sine of x, that's going to be 5 over 10, right? Sine of x is opposite over hypotenuse, which is just 0.5. So now how do I solve for x? Remember, when you solve for something, the 3 principles of solving equations, the main goal is to get variable by itself. To eliminate, you have to do the opposite operation. Well, what's the opposite of sine? You don't know. What's the inverse operation of multiplication?
Wait, I forgot.
What's the inverse operation of multiplication? Division. What's the inverse operation of subtraction?
Addition.
Addition. So you know what the inverse operation of sine is? Inverse sine is what it's called. So here's what it looks like. This is weird.
It's sine h.
Sine of -1, sine in the little -1 exponent type of thing. You're going to do that to both sides. So when you find the inverse sine of 5/10, you're going to get 30. Okay? So on your calculator, I'm going to use this calculator. So if I say 0.5, and then I'm going to do, right above the sine function on this calculator is sine and then a little -1 exponent. So I'm going to put second and then sine, and I did it backwards. So I have, and this is what most modern calculators do. You have to do it right how you just see it. So I want to find the inverse sine of 0.5. So second sine, so inverse sine, you see the sine to the -1 and then parenthesis, and then I'm going to put 0.5. I'm going to hit equals, and it's going to say 30. Okay? So do you guys have calculators with you? All right, let's try one and see if you guys can do this, okay? So basically, theta, here's what it ends up being. Theta, if we're looking for theta, and usually it's not like X angle. With angles, they use Greek letters. And so this is going to be theta. And you guys might have done this in physics if you're taking physics. But basically, theta equals the inverse sine of whatever opposite over hypotenuse is. Okay? So to find theta, you basically find the inverse sine of whatever opposite over hypotenuse is. Okay? So theta could also be the inverse cosine of adjacent over hypotenuse. Okay? And it could also be the inverse tangent of opposite over adjacent. Okay? All right, so let's try an example. I'm going to find theta to the nearest degree. Here's example 1. Here's my triangle. Here's my theta. Here's some numbers. Okay, so what trigonometric function are you going to use? Sine, cosine, or inverse cosine, inverse sine, or inverse tangent? What are you given? What sides are you given in relationship to theta?
Adjacent and hypotenuse and opposite.
Right. So in respects to theta, there are 3 sides because there are 3 sides of a triangle. There's the side opposite that angle. Do you see how 12 is opposite of theta? Okay. And then do you see how 15 is the hypotenuse? Because that's the side that's opposite the right angle. The hypotenuse is always the longest side. So they give you the opposite and they give you the hypotenuse. Which one deals with opposite and the hypotenuse?
Sine.
Inverse sine. So see if you can do that on your calculator. See what you get. I'm going to do it slowly. So do you see how we're still, if you did it this way, you can start like this. You don't have to start with the weird thing that you have to memorize. You can start by just saying sine of theta is just opposite over adjacent, or hypotenuse, so 12 over 15. And then to get rid of that, you have to do the inverse function, which is sine of -1. Do whatever you do to one side, you have to do to the other. So you end up taking the inverse sine of 12/15. What'd you get? Did you do it yet? Do you know how to do it? Let me see you do it on your calculator. Okay, so on an iPhone, you have to do it backwards. You have to do 12 divided by 15 first. So 12 divided by 15, and then hit equals. And hit that second button. So see how that turned that sign into a sign negative? So hit that, and that's your answer. Okay?
And then put it this.
Yep. Oh, no, that's sign H, and it's called a shine.
And, oh, this.
Yep,
this
that one. That's it. Good job.
So,
Figure it out. So you got that, 12 divided by 15. Now hit the second button. And see how that sign turned into a sign -1? So hit that, there's your answer. What do you got? That's it, good job. You guys get it?
I think so.
Yep, that's it.
It's just still right.
All right, yeah. So on these calculators, these are a lot easier to work with than iPhones, but iPhones are functional because it goes left to right. And actually, like an Android, the calculator that comes on that is much better than this too, because that goes left, you can go left to right with it. Okay, but yeah, so I'm gonna hit sign. So I'm gonna hit second, sign, and then 12 divided by 15. And then I can put another parenthesis if I want, equals, and then 53.130. Usually you round angles to the nearest hundredth. So we're gonna say approximately 53.13 degrees. Okay, so that's cool. That's how you find an angle in a right triangle. We've never known how to do that before. Okay, one more. Let's do two more, and then we'll call it good. So here's example 2. So here's what it looks like. I want to find theta in example 2. And I'm going to do example 3 as well. I want to find theta in example 3. Okay, see if you can get those two. The hardest part is just deciding which one you're going to use. And then you just plug it into your calculator.
wait, which one are we doing?
Well, example 2 and 3. So you're finding theta. You see where theta is on example 2, that bottom left, or the left one. And then the example 3, it's that top angle. Is theta.
Oh, sorry. What are we doing?
Example 2 and 3. So find theta.
Same thing as I just did.
Yep, except you're not going to use inverse sine. You're going to use something else. Do you have an answer
Yeah,
for example 2?
yeah.
What'd you
I
get?
don't think it's correct, but I got 20.56.
It's not correct.
Okay.
But what did you do? Did you do inverse sine? Yep, so it wouldn't be inverse sine because look at theta. So what sides are given? What'd you get?
69.43.
Close. That's close to what the book says.
What does it say?
Error message, whatever I tried to do.
What does it say? Because that's what this
So what function did you use?
Cos.
Yeah, inverse cosine of what over what?
13/37.
Yep.
Did you get
So
0.43?
adjacent.
Yeah, I did it correct this time,
Yeah,
and I
it's
got
13/37
6.43.
to that. Was it just simple? Was it?
Yeah, so do it again.
Did you get 0.43?
Yeah.
Oh, okay.
What does the book say?
What?
What does the
Well,
book
he
say?
got the same answer as you. Maybe I gave you the wrong.
I got the same answer.
You know what? You're right. You're right. This should be a 15 here. So yeah, 69 point something is what you should get. Is that what you guys got?
9.40.
So do you see what you did? So in this theta, do you see that this side, what is this side, what is this side, and what is this side in respects to theta? Well, this is the opposite of theta, right? So there's two sides that are basically part of that theta angle, right? But this one's the hypotenuse, so the 13 has got to be the adjacent. So the adjacent side is whatever side is a part of that angle that's not the hypotenuse. So it's relative, depending on, so if I pick this as theta, then this would be the adjacent side, and this would still be the hypotenuse. The hypotenuse never changes, but these guys flip around. These opposites and adjacent sides, it depends on what angle you're talking about, okay? All right, do this one. Find theta there.
34.51.
Find it in example 3.
Is it 30?
I heard you.
Okay.
It's not.
Is it 46.5?
No, did I write the problem down wrong again? No, no, I wrote it down right.
Is it 46.6?
Nope.
Is it 46.56?
49.
What?
55.
It is. How'd you get that, Janae?
I think I did the 16 over 11, right?
Okay, but which function did you use?
The tangent.
Right. So look at theta. What sides are you given? Ava, can you see what sides you're given in relationship to theta?
Oh, I didn't look at that.
I'm so confused because it's the opposite.
The opposite.
Of the
See how 16 is the opposite from theta? And then this, what side is this? What side are you missing?
Hypotenuse.
That's the hypotenuse. But you're given the opposite, so this must be the adjacent. So now, which one of these deals with opposite and adjacent? Tangent. So theta is inverse tan of opposite over adjacent, so 16 over 11. And then when you plug that into your calculator, you get approximately 55.49. Is that what you said? Okay, good. You guys see what you did wrong?
Yeah.
So it's all about picking the right inverse function. Now, the way you pick that is you have to figure out what side you're given. If you're only given the opposite and adjacent side, well, technically, you could find that third side, couldn't you? You could use the Pythagorean theorem. If these confuse you, then just force the trigonometric function that you like. But you can find the third side by using the Pythagorean theorem, but then you're going to have a weird decimal, which is fine. But that's it. Does that feel all right? Okay, so there's lots of practice there in your homework. That's it. Good job.
Black man, give me some math and I'll give you some flack. Black man.